Last year, I wrote a position paper about the AI researchers who make question answering systems and what they can learn from trivia nerds. Given the time constraints of the conference and the need to be more academic, I couldn't say everything that I wanted to. So I'm going to expand on that video a little bit more, with the aim of not being too repetitive here. What I would like to do is talk more about how the trivia community has learned hard lessons and how the question answering community is still learning those lessons. I'm hoping that by going into a little more detail about how the trivia community made mistakes, it might prod computer scientists to see how those mistakes might be relevant to the mistakes that they're making when they train and evaluate computer question answering systems. Even if you don't care about question answering specifically, I think this will help get ideas across about how to do effective evaluation in machine learning. Okay, so what are the hard-won lessons of the trivia community that the geniuses working on AI have yet to master? 1, don't cheat. 2, reward knowledge. And 3, write good questions. While that may seem simple, it took a while for humans to figure out those things for human trivia competitions, and the artificial intelligence community is still figuring it out. So let's first talk about lesson number 1, don't cheat. As veterans returned home from World War II, there was a huge thirst for new forms of entertainment. The Manhattan Project and the space race showed the importance of knowledge and expertise, and the GI Bill turned open the taps of knowledge to an information-thirsty populace. Those trends were naturally reflected in popular entertainment, as new quiz shows like 21 sprang up.
There's $69,500 still at stake, although now at $2,500 a point. The category is newspapers. How many do you want to try for?
I'll try 11.
The toughest question of them all. One of the most revered names in American journalism is that of a Kansas newspaper publisher who died in 1944. Tell us this man's name, the name of his newspaper, and the title of the editorial he wrote, which made him and his paper nationally known.
The name of the editor is William Allen White.
That is right.
His paper was the Emporia Gazette.
That is right. Finally, for 11 points,
I'll
the title...
I'll have to think a little bit about the third.
So what's the matter with 21? It was rigged, as Herb sandbagged to let his opponent win, as documented in the 1994 movie Quiz Show. The handsome Charles Van Doren was able to peek at the answers and did pretty well. Now, the obvious version of cheating is something that we don't often see in AI research, but there are subtler ways that systems, after a manner, cheat. Let's think about this very abstractly. Let's say when you are asked some questions, you get to absorb some information that you can use next time. Now, in the 21 cheating scandal, the process allegedly went something like this. Hey, let's try practicing some questions. All the ones in green you got right. All the ones in red you got wrong. Ooh, you actually got 2 wrong. So here are the correct answers to those questions. Don't tell anybody though. From an information theoretic perspective, you could then compute the total length of the correct answers, and that's how much information leaked from the test set. That's a lot. Now let's compare this with a more reasonable, in quotes, system that resembles what you might actually see for a lot of question answering data sets. You can submit a system that answers questions, usually as a Docker container to make sure it doesn't phone home, and then you get back a score. This score tells you how well you did. There's no problem here, right? You don't know what the answer is after all of this. But don't forget that computers have infinite patience. Think about this like cracking a password or solving a Wordle challenge. You could try all possible combinations for position 1, all possible answers for position 2, etc. But computers can crack a little bit more cleverly. You have a set of answers and have some confidence on each guess. Take your lowest confidence answers, change it up. If the score went up, then the guess went from wrong to right. If the score goes down, and now you know the answer to that specific question. On the other hand, if the score went down, the guess went from right to wrong, and you can do something similar. If the score stayed the same, the guess stayed wrong, so keep hunting. But in this example, the score went up, so we know that the answer was actually correct. Nobody explicitly told you that the answer was Uluru, but the effect is the same. If you do it this way, there are thousands of possibilities to try, not millions. And this is clearly in the realm of possibility for computers. Even if you can't probe every answer, you can still crank up your score quite a bit. And don't forget that outcomes are correlated, so you can often try multiple ones at once. Now, I don't think people would actually systematically do it this way, but there are many black box neural network optimization toolkits that adjust the many parameters of a neural model, often on dev data. And implicitly, even on test data, you get higher numbers for some models than others, and that's a signal. People try out many different models and just use the highest score as a legitimate representation of a system or technique. Jesse Dodge has done some great work on how to fairly report experimental results without cheating. Essentially, you need to have a budget of how many comparisons you're going to make, and then you need to apply the same budget to every system fairly. And this is why I think the human model for comparing question answering ability, that is a trivia tournament, is the model we should follow. You only get to run on the test data once. And yeah, maybe the reason is that for trivia competitions, you can't wipe human memories, but I think it's more realistic even for computers. You only have a single chance to make a first impression on a user. And this is why this is also the model that happens for DARPA evaluations. Now, bad stuff happens in this style of evaluation. We had a particularly embarrassing outing in 2016 when we lost very badly against some smart humans.
The poem's title character is told to set his foot on the sill of shade. The speaker of this poem notes that early enough through the...
To an athlete dying young.
Yes, that's power.
It's very impressive.
And to the final toss-up. This group is the namesake of 3 byproducts of fatty acid breakdown made by the liver in absence of glucose. Compounds with this functional group can undergo tautomerization in acidic or basic conditions to form enols. Player 2.
Ketones.
That is power. Let's have a big round of applause for the valiant runner-up. Congratulations on an excellent showing, Jordan Boyd-Graber and Kwanzaa.
Oh, that still hurts. But that's not an argument against doing these styles of evaluation. You should lower your embarrassment threshold, the motto of YouTube, and do evaluations more frequently. And this is why I use surprise questions for my course that I teach to see how well systems react to novel data. But it's not just the sanctity of the test set. Let's move on to how you ask questions. Regular viewers of the channel know that I'm an advocate of the Quizbowl model of asking questions, but let's dig into the evolution of this format a little bit more and see how it rewards knowledge. The mythology of Quizbowl says that it was a USO diversion created by Canadian Don Reed as a way of entertaining Allied troops in Europe. However, in my reading, it seems that a lot of the core ideas were actually introduced by host Alan Ludden once it became a radio program. It then moved to television.
Remember, teams, the next time you hear that whistle, it's the final whistle. If it blows while I'm asking a question, I stop. If it blows while you're answering a question, you may complete the answer to that one question only. I have a 20-point bonus coming up, and here's your toss-up for 10 points. What American humorist do you associate with these 4 titles? The Wreck of the Sunday Paper, The Social Life...
Rutgers, Pratt.
Oliver Wendell Holmes.
No,
If you're wrong, you lose
repeat
points.
The entire question for Goldgate for 10 points. What American humorist do you associate with these 4 titles? The Wreck of the Sunday Paper, The Social Life of the Newt, How to Get Things Done, and Down with Pigeons.
Colgate, Grote.
Robert Benchley.
Right for 10 points. Benchley.
The key idea is that the question can be interrupted, meaning that part of the skill is correctly balancing your own uncertainty, buzzing in before your opponent, but not getting it wrong, like Rutgers did. Every word is an opportunity for either team to show that it knows more than the other team. I have videos arguing for why this is the right and proper way to evaluate who knows more about a topic, so I will keep this brief here. In that 2020 paper I mentioned before, Ben Böschinge and I argued that you want question answering datasets to be maximally discriminative. See the paper for the explanations and the equations, but the moral of the story is that the Quizbowl format, popularized by College Bowl, created the right format for reliably determining who knows the most about a topic. Every question is discriminative. In other words, rewarding knowledge rather than buzzer speed or luck. You can see my other videos for why, for instance, Jeopardy isn't a good test of human versus computer intelligence. And again, see this paper for a mathematical argument for why this means you can get by with a smaller test set. If, like in Quiz Bowl, all of your questions are discriminative. But the format is a necessary but not sufficient condition. You also need to have good quality questions. Let's now turn to the final lesson from the trivia community, writing good questions. 3 heroes created the Academic Competition Federation. As a point of terrapin pride, John and Ramesh here were Maryland students. Together with Carol Guthrie, they created an organization dedicated to creating questions that fully take advantage of the beauty and elegance of the Quiz Bowl format popularized by the TV show College Bowl. So what innovations did they introduce? What does a good question look like? First, you don't want to have ambiguous questions. For example, if you ask the question, what is the capital of Georgia? And you answer beautiful Tbilisi, but the official answer is Atlanta, then you're going to be upset. Siwon Min recently had a great paper highlighting this problem in Modern Question Answering Datasets in 2020. But this was a big part of the diatribes Carol was making in the early 90s. Part of ACF style was to make sure that what they're asking is obvious as a reaction to some of the perceived excesses of ambiguous or misleading College Bowl questions. There are many dimensions to this. For example, making sure that you don't just ask when was the Battle of Hastings. You say things like, in what year, or day and month required. This is a problem in datasets like Squad or Natural Questions, where it's not always clear what's required to answer a question. Annotators just highlight whatever is convenient. So why is this a problem? Machine learning algorithms have an objective function that they're trying to optimize. If they give a correct answer, they should be rewarded when they can repeat the process on the next question. If you get the question, what is the capital of Georgia, and you're ruled incorrect when you say Atlanta, after learning the opposite lesson from the previous training example, then you're going to be upset and confused. And this is true whether a human or a machine learning algorithm. Similarly, you need to accept all the possible answers to a question. Again, we see the same pattern as before. Research papers are only now, in 2021, recapitulating the lessons learned by the trivia community 40 years ago. A great undergrad I'm working with showed that this can make machine learning question systems more robust. If you only accept Timothy Donald Cook as the correct answer to who is the CEO of Apple, that makes Tim Cook as wrong as Tim Apple. Again, this confuses algorithms that are trying to learn how to answer these questions. And even if you roll your eyes when Jordan goes on about this trivia nonsense, if you only care about climbing the leaderboards, we recently had a paper explaining how to squeeze out a few more points by paying attention to this sort of thing. Another organization that should be mentioned in the promulgation of Good Quiz Bowl and good trivia is the National Academic Quiz Tournaments founded by R. Hensel. Not only have they created a system of good, discriminative, high-quality tournaments for middle school and high school students in North America, they also have served as the employer of folks like Ken Jennings and Larissa Kelly of Jeopardy fame. And full disclosure, me too in the early aughts. And this has made Quiz Bowl more professional. Here's Ken Jennings extolling the virtues of Quiz Bowl in an NAQT promotional video.
You play Quiz Bowl because it's fun. I think we all carry around in our brain just years or decades worth of facts. Well, one thing that's important about Quiz Bowl is how it reinforces the idea that there is this canon of essential knowledge that kind of keeps our culture united and ticking. You know, it's not fashionable to stuff students' heads with facts anymore. It's more important to teach them how to learn, right? To teach them to love learning so they can pursue their interests themselves. I think one risk of living in a culture of specialization, the way we do today, is that we don't understand each other as well. The beauty of having a kind of a cultural canon of names and stories is that we all understood each other's references.
One of the things that NAQT's information technology infrastructure allows is rigorous, consistent normalization of potential answers to a question. There are many ways that this is relevant. Things have different names because of language, history, pen names, nicknames, convenience, mathematical equivalence, or domain-specific rules. The new professional organizations for trivia, like NAQT, have created systematic evaluations that, because the goal is to reward knowledge, also are the kinds of rules for judging the correctness of machine answers. Even if a user might prefer to get their answers in Fahrenheit, the computer should know that 0 Celsius and 32 Fahrenheit are the same darn thing and can be the same correct answer to a question. But these organizations are not just question writing organizations. Their goal is to create efficient systems for, as quickly as possible, determining out of 256 teams at a convention center who knows the most. In addition to the Quiz Bowl format, the selection of appropriately difficult questions asked at the right time to the right teams makes this possible. Here, I don't even have a perfect recent paper to flash on the screen to share that, yeah, computer scientists finally are figuring this out 40 years too late. We've been working on using adversarial examples and item response theory, but there's still quite a ways to go to match the beautiful efficiency of trivia tournaments, to determine which of two systems or teams is smarter than the other. But there's still quite a ways to go to efficiently figure out which of two systems can answer questions better. So as we wrap up, let's take a look at how computer comparisons lag behind those for humans. While there are monthly competitions to see which human can best answer questions, computers are reusing stale data from 2018 to see who's best. And those questions are written by random people on the internet, either crowd workers or users of Google. And those users of Google are, by definition, people who don't know much about the topic. That's why they're Googling it. In contrast, domain experts are writing questions lovingly edited by people like Ken Jennings and Larissa Kelly when people go to NAQT or ACF competitions. And while things like Dynabench are trying to create adversarial datasets, or our own TrickMe interface, these datasets are tiny compared to the tens of thousands of questions written every year for human trivia competitions. I, of course, think that this is a possibility for synergies between the two communities. Computers can help find patterns and reduce drudgery, make human trivia more exciting and efficient, and the trivia experts, with their depth of knowledge, can help computers understand more of the world. Likewise, as the best practices of the hard-won victories of the last 70 years of trivia can help machine learning researchers avoid repeating the same mistakes. And most importantly, I think it can be fun for everybody, especially us as researchers. This is just a single lecture from a course. YouTube likes to show you these videos out of order, but if you go to the course webpage linked below, you can see the lectures in the right order, and you can get resources like homeworks or suggested reading. You can also visit quanta.org if you want to learn about our systems for creating computers that can answer questions, where Quanta stands for question answering is not a trivial activity. If you want to help the channel, provide a big gradient to the algorithm by liking and subscribing.